limit as z goes to -3 of 1 over z plus 1 over 3 over 1 over z plus 4 plus 3 over z. Let's start by plugging in a -3 for each of the z's. We have 1 over -3 plus 1 over 3 divided by 1 over -3 plus 4 plus 3 over -3. In the numerator, we have -1/3 plus 1/3. In the denominator, we have 1 over -3 plus 4, which is a 1. And then we have 3 over -3, the 3's cancel to be a 1 with a negative. In the numerator, we have -1/3 plus 1/3, which is a 0. In the denominator, we have 1 plus a -1, which is also a 0. We have the 0 over 0 indeterminate form. Since we have fractions, we're going to try the common denominator method to rework this. Now we actually have fractions in both the numerator, there's the 2 of them, and the denominator, there's the 2 of them. For the numerator, the common denominator will be 3 times z. I need to multiply the first fraction by 3 over 3. So 1 over z times 3 over 3. And then the second fraction, which is a 1 over 3, I need to multiply by a z over z to produce the common denominator for the numerator fractions. Now in the denominator, I also have 2 fractions whose denominators are z plus 4 and z. The common denominator will be z times z plus 4. Remember, you can't add anything on to make a common denominator. It's all about multiplication. So we have to have it as z times z plus 4. So the first fraction, we're going to multiply by z over z. And the second fraction, we're going to multiply by z plus 4 over z plus 4. This will give us limit as z goes to -3. In the numerator, multiplying those fractions, 3 times 1 is a 3, 3 times z is a 3z, plus 1 times z, which is a z, over 3 times z, which is a 3z, divided by, in the denominator, 1 times z is a z, and then z times z plus 4 will just keep as z times z plus 4. It's best to keep it factored out. In the numerator, we have 3 times z plus 4. In the numerator, you actually want to distribute it. So the 3 times z plus 4 will be 3z plus 12. And in the denominator, we will have z times z plus 4. We're going to keep that one factored. We need to multiply out the numerators because we're going to add these fractions together. The denominators, we just need to keep them common denominators, and so there's no need to multiply them out. It's best to keep it factored because the factors may cancel or simplify in the end in some way. All right, in the numerator, we have 3 plus z over 3z. In the denominator, we have z plus 3z plus 12 over z times z plus 4. We can simplify in one more step. Specifically just down here in the denominator, we actually have a z and a 3z that can add together right there in that numerator. Other than that, I'm going to keep everything the same. So our fraction in the numerator is 3 plus z over 3z. And then our fraction in the denominator, z plus 3z, is 4z plus 12. All of that over z times z plus 4. All right, our next step now is to reciprocate the denominator fraction and multiply with the numerator fraction. The numerator fraction is 3 plus z divided by 3z. The denominator fraction, when reciprocated, which will interchange its numerator and denominator, it'll be z times z plus 4 over 4z plus 12. And now we can multiply these fractions with each other. This will give us limit as z goes to -3 of 3 plus z times the z times the z plus 4 divided by a 3z times a 4z plus 12. Now, since z is going to -3 in this limit, it's a z plus 3 factor that we should expect to have canceled to remove the 0 over 0. Now, it turns out if you look at it here, there is a z factor that cancels there and there, but that's not the sufficient cancellation to remove the 0 over 0. Though you can do it, it'll simplify the numbers that we have to plug in. It's the z plus 3 we need to get to cancel. Now, we have the one in the numerator. It's right there. We don't have one in the denominator, but we have this here, which actually, if you take out a common factor, should produce that z plus 3. So we will have limit as z goes to -3 of 3 plus z times z plus 4 divided by a 3 times a 4 that we're factoring out times a z plus 3 after we factor the 4 out of there. Now we have the 3 plus z and the z plus 3. The order doesn't matter when you add things, so we can cancel those out immediately. There was the 0 over 0 being produced. We've now removed that, and that means we should be able to plug in the -3 for each of the z's, and we should not be producing the 0 over 0 result any longer. So now we'll plug in the -3 for the one remaining z, and that will be -3 plus 4 over 3 times 4. -3 plus 4 is a 1. 3 times 4 is a 12. We get a 1 over 12.